Hey, what's up? It's Jake. We've been talking a lot about remote state in Terraform Cloud, and so now I'm going to switch it up and go to using AWS for remote state. So I copied my single server configuration into a remote backend AWS directory, and it's all exactly the same. Um, and I did a Terraform init and a Terraform plan. Actually, I applied this one too, so I could create a state file. So when you do a plan, it's going to create a lock file. And this lock file is just giving you, hey, this is the most current lock that I have for this directory, right? And if you had this on your computer, you'd have a lock and it would have a different hash value. Once you run apply, it creates a state file. And we've talked about what a state file is, but we haven't really looked at one. So if you click on it in your directory, you can kind of see what version I'm using, the output of the values, any of the output values that I have configured, like in here, I've got this output configured. And it's basically a diff between what's on your computer or in your repo and what's in production or whatever environment in real life, right? So it's just basically all the stuff that I'm using, and I can see like IDs and pretty much every piece of metadata that you could possibly want. And it's kind of acts like as like a private IP, if you want to think about it that way, where we're giving all this information to Terraform to say, hey, this is what I have, compare it against what AWS has. Um, so with going to AWS, it's a little bit different of a process, but I just want to make sure we understand what state is, how to find it, how to read it, what's in there, the difference between state and a lock, and then kind of go into a little bit of why is this necessary, right? So we're going to use S3 for shared storage. Okay, so if we go look at my AWS S3 LS, we go take a look at a list of my S3 buckets, and I've got some CloudFormation stuff. This is from my deployment that I did with Docker. Me and my buddy Casey messing around, and then some internal stuff that I have. So I want to make a new S3 bucket. So you can do this one of two ways, right? You can go to S3 and just make a bucket. But I think it's good to learn both versions. So normally in the console, you would come here and I would create a bucket, right? So how do you do AWS S3 create bucket from CLI? So you just Google and you'll see this little create bucket guy. Okay. And then there's usually some examples you can kind of look at. Let's go find one. Here you go. S3 API, create bucket, my bucket, and then the region. Okay, so there's one example. So if I were to go, I've never had to use S3 API. I just used S3. Let's try both and see what happens. So if I do AWS S3 create bucket, and then let's just call this remote backend AWS region US East 1. Let's see if this works without the API. Let's see, AWS error LSCP MB. Oh, yeah, because we're not using this. So if you use this, for example, and you just hit enter, you can get an error and it'll tell you what you did wrong if you pass some arguments. So the MB here is make bucket. So if I do make bucket, and it'll be like, we need a path, right? So you can kind of get your way through that way, S3 MB command. Google it, MB, and then your bucket, S3 my bucket. Okay, so let's try that. So S3:// let's do a little more specific. Terraform remote backend, and then we'll do region US East 1. Bucket already exists. Bucket name available. Okay, let's make this really specific. Nimbus DevOps remote backend. Make bucket. Yeah. Let's go check. Okay, so then do a little refresh. Boom, there it is. All right, so you can do it that way, or you can just click create bucket and go through this whole process. Either way, so you make your bucket, and then we're going to stick our state file in the bucket. So why do we want to do that? So let's say me and, well, we got my friend Casey up here, you saw, are sharing a repo and working on a project together. And I want to make a push to my repo and deploy that infrastructure. And let's say that whatever he's working on, he's been doing something a little different. So his state file is different than my state file. So we want to use a shared state file and make sure we have the same state. So if we want to do that, then we need to stick the state file somewhere that's not on my computer. Okay, so we're going to put that in S3. So how do you do that? There's other problems with this that we're going to get to. If you're already thinking, well, what about locks? Just wait, we'll get there. So we've got an S3 bucket. Now what I need to do is, and I could have just made this in here too. Let's try this. So let's say I want to do, as part of my main, I'm going to do a, let's do resource AWS S3 bucket, and I'm going to do Nimbus DevOps Terraform state. Okay, and then we're just going to take this guy, and just to make sure we don't get confused, we'll just delete it. Boop, boop, just like that. Okay. I mean, since we're building stuff with Terraform, we might as well make the bucket with Terraform, right? All right, so bucket equals, same thing, Nimbus DevOps Terraform state. And then that's it. So let's say we want a history of our state files. So I would put in a lifecycle. The lifecycle would be prevent underscore destroy equals true. And then that'll just make sure it doesn't accidentally get deleted. And then let's turn on some versioning. Versioning enabled equals true. So we can see different versions of our state. And then I'm going to go ahead and also turn on server side encryption configuration. And I'm going to make a rule that says apply server side encryption by default, and we're going to use the algorithm AES-256. Is that everything? Boop, boop, boop. And then this guy, let me move these. These are supposed to be part of this. There. Okay. So this is part of my main file, right? Which is like part of my whole run, my instance, my AP, like blah, 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 blah. I wouldn't do this. If I was doing this in prod, what I would do is I'd have a separate section just for this kind of stuff. AES 256, AES 256, CSSE algorithm. Argument name SE is not expected. Did you mean SSE? Algo rhythm? Yeah, I guess it helps when you can spell. There we go. Terraform plan. All right, so before we actually apply, just to make sure that this looks correct. All right, one to add. Cool. And you can see it tells you what you didn't choose. Like I didn't add MFA delete, and I didn't add all this other stuff. So I'm going to run a Terraform format. Okay, my formatting is good. And let's also validate our configuration, which I ran a plan, so it should still be good. And then we'll go ahead and run an apply, and then we should get a bucket. Now you don't have to version it if you don't, like if you're just taking tests and stuff and you don't want to have a bunch of objects that you only have to pay storage for. If you want to turn off the prevent destroy, you can do that. You don't have to encrypt it. Like a lot of this stuff is just things that I would do, that made sense to me. All right, so here's our bucket. Let's go take a look at our properties. And we can see here, versioning is enabled, MFA is disabled, encryption is enabled, using SSCS3, and everything else looks normal. All right, cool. So now we have a bucket. Ta-da! And then the next thing we need to do is, so this is where it gets kind of tricky. We need to create a DynamoDB table. So if you've never used DynamoDB, it's basically a database that stores JSON objects. So a table is a JSON object. An object in a table is a JSON object. An object within that object is everything is an object. And what we're going to use that for is we're going to use that to store our locks. So this lock here, this object, this will be an entry in the database, so that when we run a Terraform plan against our repo and it hits that Terraform state file in S3, that it's also going to use DynamoDB to store the lock, so it can sequentially lock things and know the order in which things should be locked. The benefit to this is that a lot of people store state in S3, but if you don't use some sort of locking mechanism or strategy, then everybody can update state all the time, and you could end up with people updating the state at the same time and then end up with a corrupted state file because nobody knows, there's no locks, nobody knows who's doing what when. So that's kind of the idea. So we need to make a table. And I guess we could just do that right in here. We'll just make this whole thing a giant example. Okay, so we're going to do AWS as the provider, DynamoDB table, and we'll name it Terraform locks. And then the name of this table shall be Terraform locks, I guess. It's just as good a name as any. All right, we got to put in a billing mode. And you can look at the documentation for this to see what's required, what's not required. I'm just going to do pay per request. That's what I would recommend. And then we're going to add a hash key, and that's going to be the lock ID. It's going to be our hash key. And then we're going to add a little attribute at the end to do the name is lock ID, and the type is going to be string. All right, so that'll be our hashed out lock ID that is used as a hash key. We'll pay for billing mode, and then now we have a Terraform locks name. I don't know why I'm using hyphens and underscores. I should pick one or the other. All right, so here's the thing. I can make this, right? The issue is it doesn't do anything, right? So if I do a Terraform plan, what you're going to see is it's going to go, oh, you want me to make a DynamoDB table if I typed everything correctly. But it's not actually using it, right? We named it stuff that makes it look like it's using it, but we're not using it. So let's just make sure this updates correctly. So essentially we need to change the configuration to say where the remote end is going to be managed, and then re-perform a Terraform init so that it points to the new initialized configuration. Okay, so we can go ahead and apply this and make our DynamoDB table. All right, so we got a primary key. Now, just so you know, you have to have a primary key named lock ID to use this, or it's not going to work. And it also has to be this exact capitalization, capital L and the capital ID. Okay. All right, looks good. Cool. By the way, all this does is make a hello world. All of this just for, of course, a little hello world thing. Okay, so we need to get, we got our init, we got our apply, go through my checklist here. We can make a bucket, we made the table, that's all good. All right, so now we need to configure Terraform for the backend. So there is a Terraform block that we need to put in here. And I could even make like a new file, backend.tf, and we can just say Terraform backend equals, oh wait, not backend, equals backend. Is the name of the backend we want to use. So it'd be like S3, for example. Backend, back and S3. Okay. What about the S3? Okay, well, we need a bucket. Rather than make vars. All right, so let's just cut this. Don't save. Backend, go away. I'm trying to do this that doesn't take 8 million hours. So normally what I'm thinking right now, in case you're wondering why I'm doing this, I need the bucket name. And so I'm just going to grab it from here instead of putting in a name with the variable, which I could totally do. I should, huh? I'm being lazy. All right, let's just do this. Let's go into variables. Let's make a variable. Variable. If you're gonna do it right. Right? Bucket name. Description equals name of backend. Why am I typing underscores? Name of backend bucket. Cool. The type is going to be a string, and the default value of this the default value of this variable is going to be the name of my bucket. Save Terraform format because I'm lazy. Cool. What is this? Main line 75. Yeah, we're getting there. I didn't finish any of this yet. Okay, so bucket equals var.bucket name. Hey, you're supposed to tab. So now that I have a variable, I can cut this out and I can make a new file and call it backend.tf and then paste this in here. Okay, cool. That works. Buckets. All right, so now we need a key. So this one will be global S3, and then it'll be terraform.tf state. This also needs to be in quotes. My other one's not in quotes. Why? Because it's a var. That's why, in case you're wondering. All right, and then region equals var.region. Did I make a region in vars yet? No, probably should. As you do this more and more, you're going to want to have all these things. Let's just say my default region, and then we're going to call it US East 1. Swiss, US East 1. Save. Backend. Okay, now that'll work. Next, I need the table. DynamoDB table equals DynamoDB underscore table. So let's go make one of those real quick. All right, let's copy this, stick this down here, and then let's go grab this value and turn it into a variable. And then I'm just going to call this the DynamoDB table name. What's the default value? Of course. What did we call this? Where's my main file? Ba-doop. Terraform locks. So now I can go to variables, call it Terraform locks, save, go to main, remove this, var dot DynamoDB table, and then go back end, and then that'll work. Cool, done. Next thing, last thing, encrypt equals true. Okay, so we have a bucket, right? We have a key. So this is the file path on S3 where the key is going to live. Don't worry about why this has global S3 next to it. You'll see. That's just what it should be. Okay, just that's what it is. We got our region. We got our DynamoDB table name. We got the encryption. By the way, encryption. Why why am I encrypting this stuff? We already enabled default encryption on the bucket. It's just a second layer to make sure that's encrypted. I mean, zero trust, right? Okay, so now we have to tell Terraform, hey, you need to use this backend, right? So we need to completely redo how our Terraform is currently set up. And to do that, you run a Terraform init. Variables not allowed on backend tf bar.bucket name. Oh, you can't use bucket names or variables here, huh? All right, well, I learned something today. So our bucket name is Terraform underscore state, correct? Just making sure. Name of backend bucket, Terraform, name is that's a long one. All right, so let's replace that with that. The region it's mad about, fine. We'll just make it US East 1, but now I have it for all my other places. My table, it's also mad about that. So let's go to my main DynamoDB table, which is just supposed to be Terraform locks. I should have just taken it out of my vars file. Where are you at? Yeah, underscore locks. Okay, got that there. Save. Backend, table name, locks, encryption true. Okay, so it was mad about variable. Okay, cool. Save. Try again. Key must start with a slash. Well, my key does start with a slash. I think it's because must not start with a slash. There we go. Okay, so what this is doing is reading all my files, and then it's going to take everything I used that I already made, and it's going to reinitialize the configuration using this backend, saying, "Hey, your backend is S3 with a DynamoDB table for locks, right?" And when you run this, if you've run an apply already or whatever, it'll say, "Hey, we found some state. Do you want us to move this to the backend?" Be like, "Yeah, totes. You should do that. That'd be like super cool." So it releases the lock, which goes, and that's all good. Try running Terraform plan. All right, so let's go take a look at our S3 bucket. So if I go to S3, oh, I was already in there. Let me go to the bucket. There's nothing in here, right? Cool. So let's run a Terraform plan. Actually, before I do that, let's also go take a look at DynamoDB. DynamoDB. Doing a lot of stuff here. All right, so here's our table. Sweet. What's in our table? Absolutely nothing. View items, for example. So here's a lock ID. Oh, cool. We got something. So here's an MD5. There's our digest, our partition key, and our digest. Sweet. So we've got some stuff in here. Why is it in there? Well, I just ran a Terraform init, right? And it released the lock. If you remember, up here it says releasing state lock, right? So it's doing that, and then it's reusing it, and then it's moving it. So we got an entry in our DynamoDB table. So now we go to Terraform plan. Now, just so you know, while this is running, the reason it knows to do this with locks is because the Terraform provider, in this case, Terraform is its own provider, has a backend function that can take these values, and the binary knows what to do with them. So it's already pre-programmed. You don't have to really do any extra thinking. You just go, hey, do this, 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 and it knows what to do. All right, no changes. My infrastructure is up to date. I already ran an apply. I already have a server running. So it didn't really need to do anything except for just move itself, right? It didn't detect any difference. No action. Released lock, state lock, and it's all done. So what happened on the back end? Well, if we go look at, can I refresh this? I've got a state, a lock ID, and release the stateless, so it doesn't need to do anything there because it didn't need to do anything. And then if I go, oops, tables, can I just, man, I need a visualizer. Read usage. All right, so we saw it read the DynamoDB table, which is great. That means that's working. And then we go to S3 and then do a little like refresh. See if I have a state file in here now. Haha, global S3 Terraform state file. So if you now want to go run a Terraform plan and you have the same backend configuration, right? So in my Git, which we should probably git add dot. LF will be replaced by its original route. Yes, that's good. Git commit message moved state to AWS S3 and DynamoDB. Git push. I'm just on master on the main branch. Okay, so now if you did a git pull on your computer and you change some things, right? Your computer, when you ran Terraform plan, would reach out to S3 to get the state, to check the state. And when it made a lock file, it would create a lock in DynamoDB. Okay. And so this is how we're going to manage this so we know if there's a lock or not. And the Terraform provider knows how to do all that stuff. Exceeds. Oh, I have something funny in there. Some weird exe provider. Anyways, I'll push this in a sec. So that's pretty much how that works. The other thing you can get if you you can use these output variables too, or output values. So, but after we run this command, just so you know, and it's successfully configured. We saw that here, right? All the state, like I said, S3, we already saw that. Terraform's going to pull the latest state from S3, push the state to S3. We can see the locks, all that stuff. I'm not going to put output values for my bucket name and my DynamoDB table. I don't really need to for any reason, but I'm not going to use them. But let's just go ahead and take a look at acquiring the lock state. Oh, hey, how's it going? Remote backend. There we go. So just take a look at what it's doing here at the beginning. All right, so we're refreshing our state. So where do you think it's getting that state from? Correct. It's actually getting it from S3. So right now, this is actually reading S3, which is kind of cool, right? And once it's done, like I said, I can do another apply or something, and you can see it acquire the state. All right, it didn't releases the state lock. So let's take, you say releasing state lock. So if I do a Terraform plan, it must be locking it, right? Because if I'm getting the plan, I don't want it to change. So if I run Terraform plan and then I quick run over to DynamoDB and I take a look at this table, do I have, I don't have any indexes. 0 items, get live item count, start scan. Is that a thing? All right, scan again. 1, 1, 1. Releasing state lock. It says I have 1. What happens if I do it now? 2, 2. Oh, okay, so now I have 2 locks. I have the original state lock, and then I have this plan lock. Now, why would it release the state lock? Well, we didn't actually do anything, so it's not going to keep it there. But if I run an apply, then what happens? Again, I didn't change anything, so it's not going to do anything, but I could add something just so we could see it work. All right, so refreshing state, just like a Terraform plan, and then it's going to come back and be like, releasing state lock. Boom, done. And we have 1. Makes sense? All right, so then, good old S3, 1243, date last time last modified. It's 12:51 my time. So let's go ahead and refresh this. And we see 12:50. So the state file is being updated correctly. Our locks are being released and placed correctly in the DynamoDB table. And it looks like everything is working. So that's pretty much it. If you have any questions, let me know. Fairly simple to set up, and also kind of neat. But so just make sure when you talk to people and they talk about using S3 as a Terraform backend solution for managing remote state, that you add in the extra part that will be like, well, what are you using to manage locks? And then if you need to make a suggestion, DynamoDB is an outstanding choice. Highly recommend. Fun entertainment for the whole family. So if that's it, you got any questions, let me know. But if not, then I'll move on to the next part.